Hello everyone, welcome back to the tutorials again. So in previous session we have studied about the consolidation test and even we have studied about the consolidation compressibility curve, and this compressibility curve is going to give us various values such as coefficient of compression or compression index. So formula, about the formula we have studied. Similarly, swelling index CS, about the formula also we have studied. Coefficient of compressibility definition we have studied, and briefly about the formula we have studied. Similarly, coefficient of volume compressibility or volume change MV we have studied. These two are the formula which we can use to determine the MV, that is volume change. Next, based on the various tests we have studied the various parameters. So these all the things are completed in the previous sessions. So just I am repeating the things to just make you uh, refresh your memory, to make your memory refresh. So you can see over here I have listed out the formulas by using all the data which we have studied in the previous sessions. I have listed out the formulas. So you can see first one is coefficient of compression, CC. CC is given as minus E2 minus E1 divided by log 10 to the base E2 dash sigma 2 dash divided by sigma 1 dash. So E2 minus E1, so minus sign is there. I am just taking it as E1 minus E2, just exchanging because of this minus sign. So I can say it as delta E. Delta E is equal to E1 minus E2. So this is coefficient of compression. Swelling index, so formula will remain exactly dicto, it is same, but only unloading part of the curve we have to consider. So this is the formula for swelling index. Next formula is for coefficient of compressibility, that is AV. So AV is equal to minus E2 minus E1 divided by sigma 2 dash minus sigma 1 dash, which is equal to, we are considering it as a minus because curve is in decreasing manner. Okay, so just I am in multiplying this minus sign inside. So E1 minus E2 divided by sigma 2 dash minus sigma 1 dash, which is going to give us delta E divided by delta sigma dash. Okay, next coefficient of volume change, that is MV. So for MV we are having the formulas like this. MV is equal to delta E divided by 1 plus E naught into 1 divided by delta sigma dash. 1 divided by delta sigma dash. Okay, so another formula for MV is equal to minus delta H divided by H naught into 1 divided by delta sigma dash is the formula for MV. Okay, now you can see over here coefficient of consolidation. So for coefficient of consolidation, the formula is like this: CV is equal to TV into H squared divided by T, or we can use the formula coefficient of consolidation like this: small k into small k divided by mu W into MV, where small k is coefficient of permeability. Okay, next, time rate of consolidation. So time is directly proportional to H square divided by CV. So this is time rate of consolidation. Next, there are few very important notes which I have marked down. So H is equal to H1 plus H2 divided by 2. Thickness of first layer, thickness of first layer, thickness of second layer divided by 2 for single drainage condition. Okay, for double drainage condition, it is half into H1 plus H2 divided by 2 for double drainage condition. So generally for double drainage condition we are considering it as a half. For single drainage condition we are considering it as a average. So half of this average we are considering for double drainage. So H1 is thickness of soil type 1, H2 is thickness of soil type 2. Next, second one, drainage path. So drainage path is in which TB is equal to pi by 4 into U divided by 100 square. U is percentage of you have to substitute in percentage. So U is degree of consolidation here. U is degree of consolidation. Where this TV is useful? TV is useful over here. So over here TV is useful. Next you can see time rate of consolidation. uh, for time rate of consolidation also this H is useful. Now for single layered soil, this is for multi-layer soil. For single layered soil, H is equal to H1, means thickness of a single layer for single drainage, and H is equal to H1 divided by 2 for double drainage. If it is a double drainage, we have to consider H as a half. Okay, remember this. Next you can see these are the formulas which we are going to use while solving the problem. So I have separately noted down these formulas for your convenience. Next, consolidation settlement. So SE is equal to, based on the various things we can find out the consolidation settlement. There are various formulas. So first one is based on the wide ratio. So that is SE is equal to H naught into delta E divided by 1 plus E naught. So this formula is based on wide ratio. Next, SE based on the volume change, based on the MV. So based on the coefficient of volume change, there is another formula. SC is equal to MV into delta sigma dash into H naught. So this is based on coefficient of volume change. Now based on initial and final stress, we can find out delta H is equal to capital H into Cc divided by 1 plus E naught into log 10 to the base sigma dash divided by sigma dash naught. Okay, so this is based on the initial and final stress. So you can just go through these formulas. These formulas we have derived from compression curve, which we have already studied. So I'll just repeat the thing. Just compression curve I will open, and we'll slightly repeat the things. So this is a compression curve which we have obtained from the consolidation test. So this is the loading part of the curve, and this is the unloading part of the curve. So in loading part we are going to load the specimen, and in case of unloading part, almost 1/4 of the part we are going to reduce. Almost 1/4 of the part we are going to reduce. Okay, so this is what I wanted to repeat. For the formula, as the formulas are concerned, though most of the formulas are slope of the lines which are present over here. So you can just go through these formulas further. Okay, so we'll move back over here. So let us start with a very simple problem. Okay, so I'll just read out the problem first. Problem number 1. In a consolidation test, wide ratio decreases from 0.7 to 0.65. So how they are saying it as a decreases from, and all those things we are going to study further. When the total load was changed from 50 kilonewton per meter square to 100 kilonewton per meter square. So 50 kilonewton to 100 kilonewton was the total load which was changed. Compute compression index and coefficient of volume change. So we have to compute the compression index and coefficient of volume change. So compression index is nothing but Cc, coefficient of volume change is nothing but mv. So E1 is equal to 0.7, E2 is equal to 0.65. E1 is initial and it was changed to 0.65 at the final. Sigma 1 dash is equal to 50 kilonewton per meter square. That is the initial stress which we have applied, and sigma 2 dash is equal to 100 kilonewton per meter square. That was the final which we have applied. So in this particular problem, what they are saying, in the consolidation test, wide ratio decreases from 0.7 to 0.65 when the load was increased. When the load was increased, wide ratio was decreased. How it is possible? We'll just go to this compression curve further. You can see in the compression curve, load or stress is on x-axis and wide ratio is on y-axis. So as load or stress increases, void ratio decreases. So this is what they said, as load bar stress increases, the void ratio will decrease obviously. Okay, next you can see, next uh, after this, what we have to find? We have to find out Cc and Mv. So to find out Cc, we have the formula like this. Cc is equal to delta E divided by log 10 to the base E2 dash divided by, sigma 2 dash divided by sigma 1 dash, where delta E is equal to E1 minus E2. So you can see I have written the same formula over here. So which is equal to zero point 0.7 minus 0.65, which is zero point 0.7 is E1, 0.65 is E2, log 10 to the base sigma 2 dash divided by sigma 1 dash, 100 divided by 50, which is going to give us 0.166 is the answer for uh, this particular coefficient of compression or compression index. Next, mv is equal to delta E divided by 1 plus E naught into 1 divided by delta sigma dash. So delta E is equal to zero point 0.7 minus 0.65. So zero point 0.7 minus 0.65 divided by 1 plus zero point 0.7 divided by 1 plus zero point 0.7. So zero point 0.7 is an initial wide ratio. You have to remember this. Initial wide ratio is the wide ratio which they have given in as a beginning, or as a at a certain point they have given. So into 1 divided by delta sigma dash means sigma 2 minus sigma 1 means 100 minus 50, which is equal to 5.88 into 10 to the power minus 4 meter square per kilo Newton. This is the unit which you have to mark down. This unit is very important. So unit for coefficient of volume changes meter square per kilonewton, meter square per kilonewton. Remember this. So this is Cc, this is Mu. So we have calculated all the things which they have asked. So I hope you have understood this problem. So we'll move further. Soil sample 200 mm thick takes 20 minutes to reach 20% consolidation. So one soil sample is there which is of 20 mm thick, which takes 20 minutes to reach 20% consolidation. Find the time taken for clay layer 6 meter thick to reach 40% consolidation. Assume double drainage in both the cases. So uh, they have given a particular sample on which they have conducted a test which says that 20 mm thick sample takes 20 minutes to reach 20% consolidation. So based on this, what they have asked, they have asked us to find out time taken for the clay layer of 6 meter thick to reach the 40% consolidation. Assume double drainage in both the conditions. So first of all, what we have to do here is we will consider the first case first. So that is 20 mm thick layer. So in case of 20 mm thick layer, uh, sample number 1, that is H is equal to 20 divided by 2 10 mm capital H, as they said that it is a double drainage condition. So I have clearly mentioned over here, for single layered soil having double drainage condition, H is equal to H1 divided by 2. So same thing we have done. Percentage of consolidation is 20%. Time taken T is equal to 20 minutes, which is 20 into 60. Next, what we have to find out is time taken for 40% of consolidation uh, for a soil layer having 6 meter thickness, that is 6000 divided by 2, which is going to give us 3000 mm. Now for a particular type of soil, CV will not change for a for a single type of soil. So for a particular type of soil, CV will remain constant in soil sample also, in field also. So CV for this particular sample is same as CV for this particular sample. So CV for 20 layer is same as CV for 6 meter layer. So CV we have to find out first. So before finding out CV, let us know the formula for CV. CV is equal to TV into H square divided by TRL. CV is equal to K into K divided by mu W into MV. So same formula for CV I am going to use. CV is equal to TV into H square divided by T. So I know what is T, I know what is H. I must find out what is TV. So TV is equal to pi by 4 into U divided by 100 square. Remember, U we have to substitute in percentage. U we have to substitute in percentage. So if I substitute U as a 20% for first case, then TV is equal to 0.0314. Next, after substituting TV value over here, CV is equal to 2.617 into 10 to the power minus 3 mm square per second. This is the value for CV which we are going to get for sample that is having 20 thickness, which takes 20 minutes to reach 20% consolidation. So this CV will remain constant for particular type of soil. So the same concept we are going to use to solve this particular problem. Now let us consider the 6 meter thick layer. So what they have asked, they have asked us to find out the time taken for this 6 meter layer to get 40% consolidation. So 40% consolidation they have given. So TV I can find out. So TV is equal to pi by 4 into U divided by 100 whole square. So value of U here will be 40%. So 40 is the substitution I have to do. Remember, you have to substitute it in percentage. Okay, after substituting it in percentage, TV is equal to 0.1257 value I am going to get. Next, I have to find out CV, and CV will remain same for a particular type of soil. So the value of CV I know. So what is the value of CV? This is the value of CV which we are going to get for particular type of soil. So I'm just rearranging this formula so that T is equal to TV into H square divided by CV. So CV is here, TV is here, H square is here. So T is equal to time taken for 40% consolidation. So 5003.343 days is the time taken by the 6 meter thick clay layer to get 40% consolidation. I hope you have understood. Just do the calculation. It may come in seconds, so just convert it into the days, because many of the times in your examination they specifically mention compute the time taken by time taken for 40% consolidation in days, in hours, and all those things. So like that they are going to mention. So just I have uh, computed it in days. So you can just go through these problems. If you are having any doubts or if you are facing any difficulties while solving the problem, please let me know. Okay, so we will stop here today. Next problem we are going to move in next session. Thank you.